Hello, everybody. So as Alex, I'll just reintroduce myself. My name is Michael. I'm from the Advanced Research Computing team at UBC. Part of my role is to support researchers with the cloud, including the Alliance Cloud, which is the main topic of today. So before we get started, I'll let you let me share my screen. So before we get started today, let's just do a quick LAN acknowledgement. So I am coming to you from the Point Grey campus of UBC in Vancouver, located on the traditional ancestral and unceded territory of the Musqueam people. And the Okanagan campus, Kelowna, lies on the unceded territory of the Syilx peoples. So for today's webinar, we're going to do a quick overview of what is cloud computing, and then we'll do an overview of a comparison of the community cloud, which is one of them being the Alliance Cloud and commercial cloud. Well, what's similar? What's the difference? And in a nutshell, often the term cloud is thrown around, so just a little overview of that. And then we'll dig deeper into what's available at the Digital Research Alliance of Canada and what's available at the Alliance Cloud and how you can make use of it. So I will pause throughout the session and the webinar to answer any questions. So if you have any questions, feel free to enter into chat or I could answer questions at the end of the webinar as well. So what is cloud computing? So cloud computing is on-demand availability. So it's you request or launch compute capacity, storage, things like that when you need it. So when you need for example, when you need a big workstation, you can spin it up when you need it. You don't need to purchase it ahead of time, anything like that. So that's part of how we define cloud computing. It helps deliver high-level services and access to system resources over the internet. So in comparison, your is not obviously not a workstation or a computer tower that's sitting under your desk, but it's access to resources across the internet. So some of the common services that you may be using that are making use of cloud computing includes email, calendar, or file sharing services like Dropbox, Nextcloud, things like that. And cloud computing can encompass a lot of things, including compute, which a lot of people think of, like memory, GPU, CPU, things like that, storage, but everything that connects all these pieces together, including networking, load balancing, etc. A lot of the services in cloud computing can be categorized into one of these three categories. Software as a service. So software as a service is basically it's an app a bunch of functions that you can access where you don't need to worry about how it works in the back end, what storage is uses, how it's network, et cetera, et cetera. So things like email, Google Docs, virtual desktop. Often these are services you get an account, you log in, and then you make use of the functions that these services provide. You don't need to maintain the back end of it. And then if we go one step deeper, there are services that are platforms as a service. So platforms as a service is a little different from software as a service. So it includes things like database, web servers, development tools. And the main difference between the two is that you use the functions as available for these type of service like database. You get an account, you log in and use a database like any other databases that are on physical hardware under your desk or not. But you will have to also help maintain the backend, so do security updates and things like that. And then if you go one step even deeper, is infrastructure as a service. So that's where you are connecting all the components of services together, which includes compute instances or virtual machines. So that is, again, CPU, GPUs, memory, things like that. Storage, load balancer. So these are all components of a typical architecture, and then you're connecting all the pieces together. And like platforms as a service, you're also maintaining the backend. So every month, whenever there is a security vulnerability, you're patching it, or if there is software updates for databases where you need a newer version of the database, you are upgrading it. Next slide. So we'll get into a little bit of the commercial cloud as so that's great. What's cloud? And so often when people say cloud, you think of the commercial cloud. So that will include the big ones, that often the Amazon Web Services, the Google Cloud Platform, Microsoft Azure, Oracle Cloud, and there are many others, big and small, that are available. And these are cloud providers that provide a diverse amount of services that fits into most of the time fit in one of the three categories we just discussed. And they are often as a pay-as-you-go model. So when you use it, if you use it for 6 hours, you pay for the 6 hours, for example. So some common research use cases that make use of the cloud includes remote desktop. So think of it as you need a large workstation, something that is larger than a typical laptop, computer tower that that you could purchase. But you need some sort of user interface. So you need to be able to interact with it for your research. So that could be for visualization. It could be for if you need to use RStudio or something that has a interactivity part of it, and you need a lot of memory, a lot of CPU, or a lot of GPU. So in those cases, you may need a remote desktop, and cloud is a common place where this is used for. And one other point would be if your software that you're using in your research project only runs on the Windows operating system. So you can't run those on the high performance computing clusters. You'll need to use a workstation or large virtual machines. And so if you need something large, talking about maybe 128 gigabytes of memory, larger, things like that, the cloud could also is an option for that. Machine learning, artificial intelligence. So if, yes, you do a lot of high performance computing clusters with machine learning and artificial intelligence, but if your research requires you to leverage some of the, not necessarily models or things like that, but if you're using the services that the commercial cloud providers provide, including that could be, for example, Amazon SageMaker, Amazon Bedrock, or in Microsoft Azure case, the Azure AI services, then you'll need to go to the commercial cloud for that, because those were designed and offered specifically by the cloud providers. And so that's also a common use case we've seen from researchers that would like to use, in that case, specifically the commercial cloud. Database. So MySQL, PostgreSQL databases. Yes, commercial cloud services has databases services, and I'll talk about it a little bit later as well. But the Alliance Cloud also offers that, and then that's another common use case we see from researchers that will make use of the cloud. So a little bit about the Digital Research Alliance of Canada Cloud. There are 4 sites across the country that has what we call community cloud. So not in comparison to commercial cloud, and they offer it as an infrastructure as a service. So as a reminder, infrastructure as a service, they offer the components of a typical web or um, cloud services will require. So that includes the CPU, the memory, the storage, the network, all that. So they provide all the components, and you need to put it together. But there is an interface to do that, but basically, they still need to put it all together to run it on these platforms. And they run on OpenStack, on something called OpenStack. So of the 4, the largest is Arbutus. So you often may hear the name Arbutus when you're talking about the Alliance Cloud, given it's the largest. And so we'll go into a little deeper what's available at these clouds. But the caveat, the Alliance, each of the host sites are going for a refresh. So some of these will be changing in the near future. But as of now, you can see Arbutus Cloud being the largest, has a variety of CPUs, memory, and they also have object storage and share file storage. I'll get into a little bit of that later, but it is unique to Arbutus right now, and there are different use cases for that. And let's see this list. Yes, there's also here. Arbutus Cloud is also the only cloud at the moment that has GPUs. A small size number of GPUs, but they have a little bit of GPUs. Beluga Cloud, they have CPU, memory, things like that. Cedar Cloud, based at Simon Fraser University. They also have CPU, memory, and storage. So the key components to build web servers, virtual machines. And Graham Cloud at the University of Waterloo also has CPU and memory and volume storage. Okay, so as I mentioned, yes, you have to put all those pieces together. So the CPU, the memory, as you can see on this screenshot of an interface, volumes, floating IP, which are just the IP address that is public facing. So you'll be able to access it from the web in comparison to something called private IP, which is something that is not accessible online. And all these are key components of an architecture that you may need. But we don't have to necessarily manually do it. There is a form to do that, and through this interface. So how do you get access to this resource? So you base each Canadian principal investigator can request for a rapid access service through this application form. I should have a link at the end of this presentation slide, but this is also shared later. So you'll be able to request for up to those limits any time of the year. So you can request it for today, and then the turnaround time usually within a couple of days, and you have access to up to those limits. And all we ask on the form, we'll get in the next slide on what we ask, but and it's a good way to test these resources. How does it work? Does it work with your research workflow, etc.? And if it does, and you do need resources, there is also an annual competition that happens in the fall every year, and you can request for more. So I will go through the form just as a rundown. Some of them it's pretty straightforward. Some of them I'll go over a little more detail to kind of explain what is asking so that it makes it a little easier when you're requesting for the rapid access service, or sometimes referred to as the RAS. So Alliance email, Alliance username. So basically it's the CCTV username. So what you've used for the high performance computing clusters. And the request for this allocation has to be a principal investigator. So as it says here, Alliance faculty, adjunct faculty, or librarian. There are it asks for what project type you're requesting for, and there is the compute and there is persistent. So I'll go over persistent first. It's probably the most straightforward. It's basically when you want to host anything that's like a data portal or a website or anything that it's like a platform, a tool that needs to run 24/7, usually public facing. That's where it's persistent. And so these are you'll get access to sizes of virtual machines that has a smaller amount of core and memory per virtual machine, and it's because typically in those use cases you require less to run them. So for you're running a data portal, you don't need a lot of memory to keep the portal running. You may need a lot of data storage in the back end, but you don't need a lot of memory and CPU in the front end. And then in comparison, compute is for a lot of analysis. So where you need a little bit more memory, a little bit more CPU. So we're talking about one of the example I mentioned earlier, where you do maybe need a run a user interface to interact with it. So but you're doing analysis. So you may need compute. And so these are intended for running maybe up to a month at a time, and then you shut it off when you complete that analysis, and then you launch it again when you need the resources again. Project name suffix. It's more for so that you'll be able to distinguish what it is for. So often we see DEF short for development. So if you're designing the architecture, you're trial and erroring how to put it, what works best for your research projects. So often we see that as a suffix. We also see in things like prod for production. So if you're running data portals that you're already sharing with collaborators, it's good to go. It's you're not testing anything, you're running it 24/7, then we see it prod as the suffix. So these are just the screenshots of all the different resources you can ask for and the range of resources you need. So some things I want to flag here includes floating IP. You can request up to 2. So something to consider is how many front-facing services that you need or need to be accessible by the web, but publicly on the websites, on the World Wide Web. So that's how many you'll need. So something to consider. There's also persistent storage. So those are the typical volume storage that that backs up that's part of the web services. So if you, for example, data portal being an example, you have all the CPU and memory to run the platform, but you need something to store the data, and so you can request up to 10 terabytes or 10,000 gigabytes of storage within the RAS. And object storage, similar. We've seen a common use case we've seen is for backup. So if you have a workflow where certain data is analyzed and then there's results, and then after a while you just need a backup. So we also, one of the use cases we've seen is that they'll transfer that results to object storage as a backup. And also to help clean up the volume storage especially when you have limited amount of storage space. Last but not least, the share file system storage, or it's used for when you have multiple virtual machines that needs access to the same storage bucket of data. So you don't need to have duplicate copies of the data, or duplicate storage space for each virtual machine. So let's say you have a lab of 2 to 3 students, each have a virtual machine that they're working on, but they all need access to the same set of data. That could be a one way where, and that share file system storage is architected for that use case, so then it's able to perform better where when multiple virtual machines are connected to it. Explain why you need cloud resources. So this is very critical. Where you explain to us, whoever's reviewing this request, you're requesting for these resources and what you're using it for. And that's really to check, can that use case be met with cloud computing? Not everything can be done on the cloud resources. For example, if you're running Windows software, unfortunately, at the moment, we do not, the Alliance Cloud does not have any Windows licenses available. So then at the moment, it's not available through the Alliance Cloud, but that's an example of where we check if what you're trying to achieve, can it be achieved? And then the subsequent question is where Alliance HPC cluster are not suitable for your needs. So if you're doing things like data portals and things like that, or you want to run your own database for any reasons. So those are typical answers we've seen, and that makes sense because you can't run databases on the HPC cluster. You can't run a data portal on the HPC clusters. And the reason we ask this, and sometimes we double check, is that especially with the Alliance Cloud, you may not be able to get the same performance as you will on the HPC cluster because at the end of the day, the computing, the Alliance Cloud does not have as much of memory or CPU cores as you typically could get access to for the HPC cluster. So we can take a look at that to make sure you're getting the resources that could be best used for your use case. Here, how you eventually use the cloud resources requested, basically how you plan to use those resources. Like, are you going to how you're divvying up and things like that. But the one that we want to more focus on for this slide is the maintenance and security upkeep. We just want to make sure that for everyone that's doing that wants to use the Alliance Cloud is aware that they are responsible for regularly applying security updates to their virtual machines, to the compute resources, and the software that you're planning to run on it. So if you have, whether it's open source or it's licensed software, if you're running on these virtual machines, you should be aware that you should plan to upgrade it, update it on a regular basis. And what's your plan? Do you have a graduate assistant, a research assistant that is been delegated to maintain them? Do you have a IT person on staff or someone from your department that's going to be maintaining them on your behalf? Something like that, just so that there is some sort of plan in place to keep these virtual machines secure. Okay, I pause right there and see if there's any questions about the form. Okay, first question, if you're not 100% sure how much you need initially, can you change your request later? Yes. So you can start small of 4 cores, 6 cores, and then maybe 10 gigabytes of memory. Something like that. You can start small and see if that works for you, especially if you're just testing to see if it works for your workflow. And then when you realize that you do need more, or as your lab grows and you need more virtual machines, and you still have not at the limits of a RAS, then you can email Alliance Cloud support. I believe I do have the support email at the end of this slide deck, but if not, I'll put it in the chat later. And you just email and saying, I would like to use more, and maybe a sentence of what you need it for, and then usually there's a quick turnaround increasing those quotas so that you could launch either larger virtual machines or more virtual machines. How long does it take? How long it takes to get the allocation through RAS? Usually 1 to 2 weekdays, depending on how busy the time of year is. Another thing to keep in mind, like for example, now when we're getting to the holiday season, there might be even it still be within a few days, but because of the slower time when there's resourcing being a little bit tighter in terms of time, staff time, it'll be slower, but it should be within a few days. Are there available examples of successful applications for RAS, or is it possible to get a sense of the sorts of RAS application that succeed? To my knowledge, there isn't any success examples available, but and just want to make it clear, it's not it's not a competition, it's not difficult. It's really just so that we get a sense of what you're trying to achieve. So from my experience, most would get allocated if it's within the limits and you have it even 1 to 2 cents is what you're trying to achieve, whether it's a data portal, you're trying to do data sharing with your collaborators, you have your lab is using a software that has a user interface so you need cloud computing. You need to test your analysis script so that you have a more iterative process to test your script, something like that, so that we have an idea that it is a match for cloud computing. Then is allocated. That's why it's a relatively quick turnaround time, is because in most cases you have an idea of what you're trying to achieve. It is then allocated. So I would say most will be approved. There you go, Alex. Thank you for providing that. Oh, there's a hands up. Yeah, maybe I can answer that question before we move forward. Yes.
Hi.
Hi.
This is Hongmi.
Yeah.
I do have two questions. The first I actually wrote in the Q&A. So do PIs have some default amounts of RAS, or it has to be requested even it's a small amount?
It has to be requested. So that's a very good question. I recognize it's a little different from the high performance computing computer cluster process. So with the Lions Cloud, all Canadian principal investigators are eligible to have access to the limits within those limits table I shown a few slides back, but it's not allocated by default. But so you go through the form, you fill that out, and then, as I mentioned, in most cases, they are approved within 1 to 2 days, and then you have access, and then you can move forward with that by requesting for your lab members to have access as well.
I see. Thanks. And my second question is, for example, I got some resources, and then all the lab members have to register or have accounts under the Alliance, right? So that they can utilize. Okay. And is my request appropriate if I use that for education purpose? For example, when I teach a graduate level course in one term.
That's a very good question. I don't see why not, especially if there is a research part of it. But if it's purely teaching, I'll have to run that by the cloud team. I haven't seen that use case myself.
I can probably jump in. So the answer is yes. If you're using it, if you're using this machine for teaching a graduate level course, then we usually approve it. So I have several cases like that in the past year. If it's a undergraduate course, then probably it will be denied simply because we officially support research, but not undergraduate teaching. So it depends on the level of the course primarily.
Okay, awesome. So the computing there on the cloud, what would be the big difference from the typical cluster that we use, CPU or GPUs there? You're probably going to cover that later, but
a little bit. And if this doesn't answer your question, I'm happy to answer those questions at the end of the session as well.
Thanks.
We're at 10:30, so I'll go through these. So what are virtual machines? I'll quickly go through these examples. I used the term virtual machines several times during this webinar, and basically it's a virtual version of a computer system. So you can think of it as almost like your laptop computer, but it's virtualized. So once you have it running, you may not be able to see the difference, but it's however it is hosted elsewhere. I guess that's one of the differences. So like a lot of examples I've given already, some common use cases for virtual machines include data portals, web applications. So that includes things that are web front facing, whether or you have some data, publicly available data on these servers or these virtual machines that you allow the public or the collaborators to interact with. These are all for examples of web app or applications. Larger computers, so I'm talking about if you need more memory to running something on RStudio, for example, that could be it, or testing. So you're running the scripts that you have it on very small data sets to make sure the scripts run. So these are commonly done on virtual machines. So I mentioned that there's difference of sizes of the persistent and compute. So in Alliance Cloud, they're called flavors. So they range from 1 core to 1.5 gigabytes of memory. It sounds small, and it is smaller than, I believe, any laptops you can get nowadays. But oftentimes it is very useful, especially if you're trying to see if this resource works for your research workflow. It's small enough, it can test whether it's functioning for you. And if it does, and you need more memory as the data sets grow, or when you go into your doing things with your actual data sets, you need more memory and more cores to actually make use of the resource, you can always change it. And it goes up to 8 cores, 12 gigabytes. I believe there's one more that's, in most cases, 8 cores and 12 gigabytes. So, and again, a quick reminder, these are for hosting things like data portals and web application, and oftentimes they don't need much more than that. So that's why they're relatively small if you're looking at compute flavors. So these are more for analysis. So they range from 1 core, 7.5 gigabytes of memory, and the 36 there signifies ephemeral disk. So these are storage that is there temporarily for analysis time, and then they go away when you shut down the computer. So it's not recommended to keep data on these ephemeral disk. So any data or results that you want to keep, it's recommended to move them to, let's say, a volume, which is persistent. And they range all the way up to 8 cores and 60 gigabytes of memory. So these are available by default, and they do fit within the RAS limits. So if you request within that range of the RAS limits, you should be able to have enough quota for these. And there are larger sizes, but then they probably won't fit within the RAS quotas. So you could then you may need to request for the annual competition for more resources. And last but not least, and this is available on the Arbutus Cloud, hosted at the University of Victoria, is the GPU. It is small compared to the high performance computing clusters. So this is one reason where the clusters would be more appropriate if you're doing a lot of analysis or machine learning, things like that requires GPUs. But it is still pretty good especially for testing. So in this case, you have 1 GPU, 8 gigabyte of GPU memory, 4 CPU cores, and 22 gigabytes of CPU memory. And that's the only size that's available on GPU as of now. Operating system. As I mentioned, unfortunately at this time, there is no Windows license. So you see here, Windows is not listed, but there are a variety of Linux versions here that you could make use of, including Ubuntu, Rocky, Alma Linux, Debian. So whichever one you're more comfortable with, feel free to use that one. And we try to keep these up to date in terms of the major versions. And storage, we mentioned these I kind of went over them quickly during the forum, but I'll go over these quickly again. Volume storage, so this is a persistent. So even when the virtual machine is shut off, these stay, so data results would not go away, would not be corrupted when you shut off the machine. And so these are typically, you think of these as the drives that you attach to these virtual machine, like almost like on a typical laptop, you might have a C drive, a D drive. It's almost equivalent to that. Ephemeral storage. So those are the ones that comes with the compute flavors. As I mentioned, they go away after you shut it down. And something that's very important because the compute flavors are intended to run for up to a month or so, and then they're intended to shut down when analysis is complete. Object storage, it's non-hierarchical storage, so there's no real concept of folders and things like that, but it's great for backup. It's good for keeping other copies of your data or results. And you can get up to 10 terabytes of it on Arbutus Cloud through the RAS, so without the competition. And then again, the shared file system storage is intended for, it's best used for when you have the storage that is attached to multiple virtual machine or instances. Snapshots. So I don't know if you caught it, but in the screenshot before it, there was something called snapshots in the quotas, and basically it helps you back up virtual machines. So one of the common use cases is when you have tried and tweak your virtual machine perfectly to how you want it in terms of just the software you want to install, all the dependencies and everything like that. You can take a snapshot of it so that you can launch additional virtual machine that looks exactly the same with that. So that's a very common use case of using snapshots. Yes, so, and the reason you can replicate these configurations because it includes operating systems, all the configurations. So if you change any of the configuration, like for example, data portals, you probably had to tweak some of that and the data. Backup, yes, backup the virtual machine. Another use case, not as common, but still pretty useful is to migrate to another cloud. So Arbutus Cloud is the largest, so most researchers will find their allocation on Arbutus Cloud, but there are reasons where you may want to move it to the other 3 sites. And so snapshots are very useful to move these virtual machines because you can take a copy of it and then move it over to the other sites. Yes, and the recommendation is shut down the virtual machine before taking a snapshot, or there is a risk of some sort of corruption that can cause errors when you're using it. Floating IP, as I mentioned before, is for public facing. So you assign an address. So there are 4 numbers, IP addresses, and it's for public facing. So I keep using the data portal as an example. So it needs to be accessed on the web, on the internet. You assign one of these floating IPs to the instance, and then you will be able to access it, assuming this security and the firewalls are set up that is accessible. Speaking of security groups. So these are groups of rules to allow or not allow access to these servers. So as an example, this is a very simple setup where it's only allowed for SSH access. So you can SSH in, but no other type of access. So you can't access it on your web browser. You can't do SFTP, maybe SFTP, but you can only go through the port 2022. It's very simple, but it can get more complex as you're trying to build up more complex architecture. Key pairs. So for security, for best practices, we require that all virtual machines are assessed with public with key pairs, with public keys, no, private keys, sorry. Basically you create key pairs or you import an existing pair that you have, and then you assign it to the virtual machine when you launch it. So that's the key that you use to SSH to the servers to access the servers. There is you won't be able to access it with a typical username password combination. Privacy and security. We sort of mentioned it, especially when we went through the forum. It's very important, especially because it's up to you or your lab, your delegates, to maintain the security of the servers. So confirm the security settings are appropriate to data you wish to store, process, or transmit through the cloud services. So it sounds like a lot, but oftentimes this could be as simple as making sure that if it's web facing, making sure they're using, let's say HTTPS, make sure it's encrypted transmission, make sure that if possible, maybe limit not to the whole wide web, maybe limit to if it's only needed to be accessed from your lab, physical lab, or your department VPN, limit that. That will help maintain the security of your virtual machines. Confirm you're complying with local legislation and your institution's policy and security standards. So part of that would be privacy impact. It could include privacy impact assessment, which sometimes is the acronym PIA, or security threat and risk assessment, things like that, depending on your institution and your province or territory. So make sure that you are complying with that. And some of the common things that would be maintaining the security, doing security updates, making sure the virtual machines are patched whenever their patches are available. So apply security updates. So here's an example for Ubuntu, 2 lines to update and then reboot the server. And then here's an example with Rocky. So I'll go for a couple examples, and then I'll answer any remaining questions. So we went through the basically infrastructure as a service available for Alliance Cloud, but some other things that are available through the cloud of available at Alliance include Nextcloud. It's a Dropbox-like cloud storage service. It's last I checked, every user has 100 gigabytes, so it allows you to sync it to your computer. You can share files, share data sets with others through this platform. So here's a screenshot what it looks like. It's very similar to Dropbox. Use cases. So I'll go for these type of use cases. Some of them we already talked about during the earlier in the presentation. So data transfer. So not necessarily a use case, but this is a very common thing. If you're transferring only couple files, you can use things like SCP and transfer files to your virtual machine so that you can use it like a data set. Or you can use mobile Xterm and then use the interface to transfer the files. Larger amount of data, you may want to consider using things like Globus or rsync. And here's a link for more reference documents. Web applications. So this is a very common things that people will use cloud for. Let's see, yes, for things like data collection, data sharing, and sharing research. And it's typically, and also for best practices, you'll have 2 servers. You see here, so you have a database and storage, and actually 3 pieces. So you'll have a web server, database, and storage. And the web, which is where the people accessing your portal would hit first, would be separated from your data, whether it's in the database or not. And that's best practice. And then that's a very common use case. Running things like Jupyter Lab. So again, interface, something that has an interface where you need to interact with it. You can use the cloud for RStudio. And I believe this is the second last, Linux desktop. So Linux does have a desktop version. You can activate that, and then you have a basic Linux computer that you can access to do your analysis. Especially if you're running certain software where you need to do a typical on the computer install. This could be very maybe a little bit more user friendly. And running your own database. Although I must add that the Lions does have a database service, so if you don't want to run your own database, you can request for database access, and that could be provisioned for you, and you will need to maintain the security updates. So it's closer to a software as a service. And here's a couple of links where the slides are shared, so you can access those later. But there's a quick start guide, so we'll go into a little deeper and step-by-step details of how you launch a virtual machine through the interface. The rapid access service allocations. So there's that where it has the table that I showed you, and also where it's linked to the forum. Nextcloud, so that's documentation for how to use Nextcloud, and also where the link to Nextcloud. And like the HPC cluster, the status of the clouds can be found on the status.alliancecan.ca. So if you find the performance is slower than normal, then maybe you want to check there to see if there's any if there's a status update. And that's the end of my presentation.